Okay, this is example to help you with question tutorial number 3 for compaction, and that tutorial is expected to be submitted on Thursday. This time around is the example for compaction with additional information, which is with field condition. Okay, let's see what you need to produce if you have this kind of question, and this is exactly the same like your tutorial number 3 uh, that include the question with field condition. So for these types of question, normally it will begin with normal question, which is they will provide you with data, moisture content, and either they give you bulk density or they give you the value for dry density. Previously, you already submit and you already solve the solution, the question for example number 2. Okay, you already know how to plot for dry density and moisture content, and from that plot you get the curve for compaction, and from the plot you get the value for dry density and optimum moisture content. And of course, with the experience, when you try to solve for question number 2, you already plot for avoid 0% and avoid 10%. So right now, let's see for this particular example. Okay, in this scenario, it gives the value of BS compaction for with the following data were collected. It's given the water content value, so we have about 6 data here, and then it gives you the bulk density value, and of course it's paired with the water content value, and the question also gives you the value of GS 2.70. And the first question is draw the graph of dry density against water content, and from it determine the maximum dry density and optimum water content. On the same axis, draw the rho d over W curve for 0 and 5% air void, and hence determine the air void content at the maximum dry density. So at least you have the idea that from this data, okay, the next procedure you will do is to plot dry density, and then to get all these points connected, at the end you get this compaction curve. And we know that for y-axis that will be dry density value, and for the x-axis will be the moisture content value. But for this particular example, the missing data is the dry density data. Okay, first you need to calculate for dry density here, and then dry density is given the equation of rho dry is equal to rho bulk divided by 1 plus W. So you will get a new value before you plot for that compaction curve. And then the question asks for maximum dry density. Again, you will plot for maximum rho dry max, and then corresponding to the rho dry max, you get the value for OMC or optimum moisture content. And of course, the question require you to draw for the rho d over W curve for 0 and 5% air voids. So you are applying the equation that you already know, the equation for air void, and that equation, next you can get the line for air void content 0%, and then you will get the air void content at 5%. So what I'm sketching here is the rough idea for the expected outcome from this particular compaction data or compaction equation or compaction question. So okay, next, what is more about this question? It is paired with the question said that under field condition, variation is in the applied compactive effort may cause the air void content to vary by plus minus 1.5%, Also, the field water content may vary above and below the optimum value by 2%, indicate therefore the range of dry densities that may be found after compaction in the field. Okay, it's quite tricky because we never see this kind of question before, but this is the lecture, or this is the description for you to at least can uh, can use this explanation to solve for this type of questions. Right. The question says that the avoid content varied plus minus 1.5%, meaning that some of the density is minus 1.5% of weight ratio, and then plus 1.5% of void ratio. And then the value for optimum moisture content is also vary at 2% from optimum, and then minus 2% from optimum. This one is a void content, and this one is moisture content. So how actually you want to draw all of this requirement in your solution. So this is the step by step how to solve for this particular question. I have already mentioned that from the data you must use rho d or rho dry equation to get the rho dry equation, the rho dry value from the bulk density value, because this question give you bulk density value. You cannot use that bulk density value to plot. So what you need to use is dry density, use this equation, and then get all the value for each moisture content for dry density. Okay, right now we have new value for dry density, which is 1.78, 1.89, 1.94, 1.95, 1.86, and 1.76. Okay, of course, you will plot. Okay, this is what you plot. This is all the points that you get from the data. So use the data to plot. Okay, don't worry about other drawing. Just follow this instruction. Okay, from the data, water content and dry density, we have all the points. You know, next what you need to do is to have all that points, and afterwards, all of that points you need to connect all the points to get the compaction curve. So next is to draw the compaction curve. Okay, I use a different color to show you how to connect all that dots to produce the compaction curve. Right. So you get the compaction curve here. Okay, you get the compaction curve. So once you get the curve, you already done for compaction curve. Next, the question asks you about the dry density maximum. So you know that you need to draw that horizontal line to show where is the rho d maximum, and that rho d maximum is at 1.96, and the value for rho dry maximum is 1.96, and corresponding to that value, that will be your optimum water content, which is given by 11.9%. So using that one, okay, you already solve for the compaction curve. From the compaction curve, you get the dry density maximum and the optimum moisture content. And then the question B asks you about using how to draw for 0% air void and then 5% air void. So the solution give you here is using equation 3.26. Okay, of course we don't mention our equation by that number. What we have is we have this equation, which is gs rho w, we have 1 plus wgs, and then you get 1 minus av. And then of course you will use this term av for 0%, and then you will use av for 5% avoids. Okay, in this solution, the solution suggests using 10% water content, 12%, 14, 16, 18, and 20 water content. And this solution give you one table to show all the value for 0% air void, and then all the value for 5% air void. So get all the value for dry density, then you get all of this point. This is the point for 0% air void content, and then using that one, we are using that one to plot for 0% air void. And then from the data table, you have this point for 5% air void. And then you connect the dot, so that one is 5% air void content. So basically, to plot 10% and 5% air void content and 10% air void content, you already done that in example tutorial 2. And plot that one. After plotting that, we solve for question B. Next is to find the value of air void at rho d maximum value. The question also asks the value for, on the same axis, draw the rho d curve for 0 and 5% air void. We already draw that. And hence determine the air void content at the maximum dry density. So at maximum dry density, the question asks what will be the air void content. So for this particular question, what you need to do is to use the equation. This one, rho dry is Gs rho W 1 plus WGS 1 minus AV, and you need to put AV as the title of the equation. Rearrange all the equation. Put the value for rho d, which is the maximum dry density 1.96, and then your optimum water content, which is 11.9, so that one will be 0.119. So GS given in the question, rho W is 1. So rearrange all of this, put it in the equation, and then you find the final answer, which is 0.0408 equal to 4.1%. So in this in this question, the answer for air void content at maximum dry density is 4.1. That one solved for question B, but you have the last condition, which is the topic for this lecture, which is to consider the field condition of the compaction. So you are using the graph here right now because you need to plot the shaded area. This is the shaded area. How to plot this shaded area? So to plot this shaded area, the condition of the soil is it has plus minus 2% moisture content, meaning that from optimum water content you find the value which is less than negative 2% of your optimum water content. So you have optimum water content which is 11.9%, and less 2%, which is 11 minus 2%, you get about 9.9%. And then this 9.9% is you must use moisture content 9.9%. For the condition 1.5% air void plus minus 1.5% avoid, negative 1.5% avoid, and then positive 1.5% avoid content. Okay, meaning that okay, because we already determined the air void content at maximum, dry density is equal to 4.1%. So if minus 1.5% air void, okay, you get about 2.6% air void. If positive 1.5% air void, you get 5.6% air void. Okay, the same here. If the minus moisture content is negative 2% moisture content, you get 9.9. And if positive value for moisture content, you get 11.9. Okay, we need this data because next, to find this dry density, okay, for field condition, okay, what you need is to use this equation, dry density GS rho W 1 plus WGS 1 minus A void. So right now, I am considering minus 2% moisture content at plus 1.5 air void. So what I'm doing here is dry density GS. GS is given by the value in this question is 2.7, and then you have raw water, which is 1. Okay, I have 1 plus negative 2% moisture content, so that one will be 9.9%. So 0.099 GS 2.7. Okay, because not right now I'm considering plus 1.5 avoids, so that one will be multiplied by 1 minus 0.026. Okay, and then you need to calculate this value. Okay, negative 2% at positive 1.5%, I get 2.08 megagram per meter cubic. So this is where the point, okay, for that negative 2% moisture content and positive 1.5 air void. So I'm doing the same for the condition of negative 2.0 moisture content and negative 1.5 air void, and then I get this value. So I'm doing the same thing for positive moisture content, positive air void content, this value, and then for negative value air void content, that value. So I'm having this area. So this is the shaded area. You need to draw for the shaded area to show that that will be the allowable field condition for this particular question. Okay, meaning that if you have data from lab, you give the contractor, but of course you cannot control what happened in the field condition because a lot of variation happen during construction site. So what you can do is use this one, this compaction for field condition. So if the contractor compact your soil within that shaded range, then it is acceptable for us to accept the compaction process. So of course you need to do the set of question. This one is related to your tutorial question number 3. So do that one. Of course, tutorial number 3 is different set of question, but the way to approach that particular question is what I have already mentioned here. So okay, that is all. Please do that tutorial number 3 to see the differences of cases for compaction. And I think this will be the last case that you can use for compaction discussion for compaction. And next what we will do is to discuss about consolidation. Okay, that's all. Thank you.